Hi, my name is Adil, physics mentor at P.I.E. As you all know, in the running like dreadful situation of pandemic COVID-19, the whole world is overwhelmed with the sense of fear. With this sense, our team P.I.E. has decided to deliver online lectures on our YouTube channel so that the career of our students will not come on hold. Now let's start with today's topic, which is friction. Now let's understand this concept of friction. Now, as I have taken the example of a block which is on a surface. Now, upon the application of certain force on this block, what we are observing that the body is in the state of rest. That means there is no acceleration produced in a body in the initials when I applied certain amount of force. But as per Newton's second law of motion, which states that if certain amount of force is applied on any body with certain mass m, there must be some sort of acceleration produced in a body. So as we can say, the equation force is equal to mass into acceleration, and force by mass is equal to acceleration. That means there should be some sort of acceleration in a body. But in the first case, we are observing that the acceleration in a body is zero. So from this conclusion, we concluded that there is some sort of hidden force or reaction force that actually balances our applied force. So that hidden force or the reaction force which tries to balance or tries to stop the motion of our body is known as force of friction. So it is because of the friction that when I applied certain amount of force on this block, the body was still in the state of rest because the same amount of force is being applied back on the block in the opposite direction of applied force. That's why the acceleration produced in a body is zero. Now suppose that here I have applied the force in the horizontal direction and the frictional force is just opposed to the applied force. The direction of this frictional force is opposed to that of applied force and the magnitude is same. That's why the applied force is balanced and the acceleration in a body is zero. Now suppose that I have applied certain force with certain angle. In the second case, you can see in the second example, I took the block and applied the force with certain angle. Now what we will observe in this case, the motion will be along the horizontal direction. Why so? Because there will be two components of the forces as we have studied in the resolution of factors. The horizontal component of the force will be responsible for the motion of this block. So that's why the body will go along the horizontal direction. Now in this case, again, the frictional force will be opposed to that of the direction of the motion, not opposed to that of the applied force. You can see in the initial case that the frictional force was opposed to that of applied force, but here the frictional force is opposed to the direction of the motion, or we can say intention of motion of a body. So from this point we concluded that the direction of force of friction is always opposed to that of the direction or the intention of motion of a body. It may or may not be opposed to that of applied force. So let's talk about the definition of this friction. Now when I applied certain amount of a force on a body, our aim was to bring this body in the state of motion. So when I applied certain amount of force in the initials, the body was not changing its position, but our aim was to bring the body in motion. So therefore I can say that that reaction force or that hidden force or that opposing force is actually tends to stop the relative motion between the bodies. So that reaction force is actually trying to stop the relative motion between the bodies in the direction, as I earlier said, that in the direction opposed to that of the intention of motion or the applied force. So therefore I can say now the direction of this force is always opposed to that of the intention of motion, or in some cases it is opposed to that of the applied force. As we saw in the previous example, when I applied the horizontal force, the force is in horizontal direction, so the force of friction was just opposed to that of the applied force. But sometimes when we applied the force with certain angle, what we are observing there that the force of friction is not opposed to that of applied force, but for sure it will be opposed to that of direction of the motion of a body. As I have taken this is the example over here, that this is the force of friction which is acting opposed to that of the motion of a body. Now what is the example of this friction? Suppose that you are walking on ground, it's because of the force of friction you are able to walk on a ground. If there will be no friction, you will fall down on the earth. We are able to write on the board, it's because of the force of friction. So when you rub the hand, when you are rubbing your hands, so there is the force of friction which comes into play. If there is some sort of honey in a beaker and you are putting down this honey from the beaker, so what you are observing that there is the slow rate of flow of this honey, it is because of the force of friction. So there is lot of examples of this force of friction. The nature of the force. What is the nature of this force of friction? So remember this thing, force of friction will be only come into play unless and until the two surfaces will come in contact. There are the two bodies, so the surfaces of these two bodies has to come in contact. Then and only then this force of friction will come into play. So that's why we say that this force of friction is a contact force. So by what we mean to say by this, that means the two surfaces have to come in contact. Then and only then the force of friction will come into play. Next, this force of friction acts tangential to the surface. As we saw that when the two surfaces will come in contact with each other, the force of friction will come into play opposed to the direction of the motion of a body, and that will be tangential to the surfaces. Next is origin of friction. Now what is the origin of this force of friction? How this friction comes into play? So perfectly, if we say that there is no surfaces which is perfectly smooth, as if we saw with our naked eyes, we sometimes say that this surface is perfectly smooth, that surface is perfectly smooth, or in magnetized rows is perfectly smooth. But if we will use the microscope, but we will observe that none of the surfaces exists which are perfectly smooth. There are some sort of undulations are there. There are some sort of irregularities, and due to those irregularities or due to those undulations, this force of friction exists. So when the two surfaces come in contact, the breakage or the formation of bond takes place. So this breaking or the formation of bonds between the surfaces arises the force of friction. Now the second origin is because of intermolecular force between the surfaces. Now when the two surfaces come in contact with each other, there is a force which exists between the molecules of the surfaces, and that is known as intermolecular force. Because of the intermolecular force between the surfaces of the bodies, this force of friction also exists. The types of friction. We have basically two types of the friction. One is known as internal friction, the another one is known as external friction. Internal friction is also known as fluid friction. Now external friction has got basically three types. One is known as static friction, another is known as limiting friction, third one is known as kinematic friction. Now let's talk about the types of frictions one by one. Let's talk about the internal friction, also known as fluid friction. Now basically what is this fluid friction or internal friction? It is resistance to the flow of fluid. Now what are fluids? Fluid is anything that is able to flow. Suppose that we have liquids. Liquid is a type of fluid. Gases are also fluid because they are able to flow. Solids are not fluid. So therefore, it is basically the resistance to the flow of fluid. Suppose that, let's take an example. We have the two beakers. In the one beaker there is honey, and in the another beaker there is water. Now when I pour the honey from this beaker, what I am observing that the rate of flow of this honey is less than that of the rate of flow of this water. So basically there is some sort of resistance or the opposition to the flow of this fluid, which is also known as viscosity. So the resistance to the flow of this fluid is also known as viscosity. So it exists because there is an intermolecular force between the layers of this fluid. So basically this fluid exists in the form of layers. So there is an intermolecular force between the layers of the fluid. That's why this fluid friction or the viscosity exists. So in case of an honey, there exists more intermolecular force between the layers of an honey, and in case of an water, there exists less amount of the intermolecular force between the layers of this water. That's why the rate of flow of the honey is less than that of the water. So we can say the viscosity is greater, or the internal friction is greater in case of honey and is less in case of water. So next is static friction. It's a type of external friction now. So what is static friction? Look, I have given the example. There is a block in which a person is pulling the block. He's applying certain amount of the force on this block. But what we are observing, that the block is not changing its position. It is in a state of rest. So remember this thing, that if this person is increasing the force, suppose that he has applied in the initial, he's applied 2 Newton of force, 3 Newton of force, and goes on up to 10 Newton of force, and what he is observing, that the body is still not changing its position. It is still in the state of rest. So we can say at that time the force of friction which is exerting on this body, on this block, that force, when it is in the state of rest, that force of friction is known as static friction. So we can say the frictional force that opposes any attempt to move a stationary object along the surface. So that means when we are applying certain amount of force and we try to bring this body in motion, but the body is still in the state of rest, so there exists a force opposed to that of the applied force. That reaction force at that time is known as static friction. So we can say a friction that exists on a body when the body is still in the state of rest is known as static friction. Now the next is limiting friction. Now I have applied a certain amount of force on this body. Suppose that in the initials 2 Newton, 3 Newton, 4 Newton, I am going on up to 30 Newton of force. When I am applying the 30 Newton of force on this body, what I am observing now, the body is just going to commence its motion. Remember this thing, the amount of the force I am applying on this body, the applied force is equal to the reaction force, or we can say the frictional force in case of static friction. How much amount of the force we are applying on the body, same amount of the force will be applied back by the frictional force on the block. That's why the block is balanced. It is in the state of rest. So we can say at a static condition, the frictional force, the static friction will be equal to the applied force. Now when I am increasing the force, now I reached up to the 30 Newton of force. Now what I am observing, that when I reached up to the 30 Newton of force, now the same amount of the force will be frictional force at that time. So we can say after, now when I am increasing a little force more, what I am observing, that the body is now going to commence its motion. It will now start its motion. Therefore, I can say that 30 Newton of frictional force is now the limiting value. It's up to this limit. That means it cannot exceed now, because the body was in the state of rest only when there was an same amount of the frictional force applying back on this block. Now what we are observing over here, that the body is now just going to commence its motion. So therefore, the force of friction will not increase now. There will be now the limiting value of that force of friction. So in that case, when this body is not now just going to commence or start its motion, the force of friction that will come into play is known as the limiting friction. Remember this thing, this limiting friction is the maximum value of the friction offered by the surfaces when the body is just going to commence its motion. So this is known as limiting friction, which is kinetic friction. Now what is kinetic friction? Kinetic friction is simply that now when a body comes into motion, kinetic means motion. When a body will come into motion, now the frictional force that will come into play is known as kinetic friction at a time when body is in a state of motion. Now kinetic friction has got two types. One is known as sliding friction and another is known as rolling friction. Now what is sliding friction? So sliding friction is a type of friction that when a body slides over the surface of another body, the type of a friction that will come into play is known as sliding friction. Suppose you can see over here that a boy is coming down, so he is sliding over this surface, right? So when he slides over the surface, the frictional force which will come into play at that time is known as sliding friction. Yes, suppose that we have the block, we have some sort of block on a ground and we are applying certain force. So we are sliding this block on this ground of force, on this ground by applying the force. So that means at that time the frictional force that will come in play is known as sliding friction. Another type of friction is known as rolling friction. Now what is rolling friction? When the surfaces of one body rolls over the surface of another body, the type of a friction that will come into play is known as rolling friction. Let's say an example, a vehicle is moving on the surface of a road. So the wheels of this vehicle roll over the surface of a road. So at that time, the type of a friction that will come into play is known as rolling friction. Now here I have taken the example is this, the skateboard. The wheels of the skateboard are now rolling on the ground. Now at that time, the force of friction that will come into play is known as rolling friction. The magnitude of rolling friction is less than that of the sliding friction. Remember this thing that the friction does not depend upon the area of the contact between the surfaces. How much is the contact of area between the surfaces? It will not depend upon that. But it strictly depends upon the nature of the surfaces, whether the surfaces are smooth or they are rough. So greater is the roughness among the surfaces, greater is the force of friction. Lesser is the roughness or smoothness, greater is the smoothness among the surfaces, so lesser is the force of friction. So if I'll draw a graph between the applied force and the force of friction, what we will observe, in case of static friction, there will be a direct relationship between the applied force and that of the force of friction. That's why the body is in the state of rest, because applied force will be equal to the force of friction. So, but there will be a maximum value. This direct relationship will be up to certain value, up to a limit. And after that value, as we know about that, the limiting friction, after that there will be decrease in the force of friction when the body will come in motion. And when there will be decrease in the motion, when there will be decrease in the force of friction, and after that it will remain static. The force of friction will remain now static in case of kinetic friction. So we can say that direct relationship would be up to the static friction, and or we can say the limiting friction. Limiting friction will be the maximum value of the force of friction. Then there will be decrease. There will be no more increase in the force of friction after the body is in motion. So then after there will be decrease, and then the force of friction will remain constant for the kinetic friction. So this is how we can draw a graph between the force of friction and the applied force. Thank you guys for watching the lecture. In the next lecture, we'll be talking about the laws of limiting friction.